Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about experimentation. This topic is based on a tech blog with the title Measuring Marketing Effectiveness in a Cookieless World, written by the data science team from Grammarly. You can find the blog link in this episode's description. Throughout this episode, we will dissect the topic from both business and data science angles. Now, let's dive in. On the business side, let's take a look at the problem to be solved. Grammarly is an artificial intelligence-powered writing assistant tool designed to enhance writing communication. It identifies and corrects grammar, spelling, punctuation, style, and tune errors, offering features like grammar checking, plagiarism detection, and vocabulary enhancement to help users write more effectively and professionally. Marketing plays a crucial role in driving Grammarly's business growth for several reasons. It increases brand visibility and awareness among potential users. By promoting its features and benefits through various channels, such as social media, content marketing, and advertising, Grammarly can reach a wider audience and attract more users to its platform. These users may then be converted into active or paying users, fueling the company's growth. In a competitive market landscape where user attention and awareness are valuable resources, effective marketing is essential for Grammarly to raise awareness, acquire new users, and drive business growth. Speaking about effective marketing, this is usually viewed through the concept of incrementality, meaning how much net new sales the marketing spending brings in. So having the right measurement approach to marketing performance is very important. This is a challenge the data science team at Grammarly aims to tackle. Now that we've understood the business problem to solve, let's shift gear and dive into the data science side to see what is a good solution. Speaking about measurement, A/B testing is often referred as the gold standard. There are generally three components involved in any A/B testing. The first one is choosing the right success metric to measure against. Usually, sales numbers, revenue, or engagement measures are considered the right metrics to use. The second component is setting up the approach to split out the control and test groups, so that the changes are only applied to the test group. The third component is to interpret the experimentation results, so that the performance difference between the control and the test group can inform decisions. Let's take a look at how these A/B testing components work for the team's marketing efforts, using YouTube channels as the team's specific example. The first component is choosing the right success metric. Ideally, this metric would be about net new revenue brought in, so the return on marketing spending cost can be directly visible. However, Grammarly has a freemium business model, meaning that when customers sign up, they are signing up for a free account with some basic functionality. Then, the customers may get active using this product later, and then the users find the product's advanced features helpful to convert it into a paid version. The conversion from a free user to paid user could take much longer time and may be a much lagging indicator of the marketing's effectiveness performance. So the team decided to leverage new active users as the success metrics instead. The second component of the experimentation is about how to split out the control and test groups. This is much trickier for the YouTube marketing channel, or in general, any brand advertising channels, because there is no unique identifier for each possible users who may see this marketing information. Without this unique identifier, it is impossible to split out users into control and test groups cleanly. If this is the case, given the nature of the brand marketing, the effect of marketing would be much minimized due to such marketing contamination between these two groups. Given this challenge, the team seeks to make the split not through a user-level identifier, but through geolocation split. This is called geo-experimentation, where one geographic area is exposed to the previous advertising practice, while the other group would go dark, meaning no advertising would be seen by anyone residing in those geolocations. This geographic splitting is much more complicated than user splitting due to two levels of complexity. One is that the team needs to select what granularity the geolocation would be made. For example, would it be split out by different states? If so, there would be only around 50 states in the United States of America, resulting in a much smaller sample size with significant variance in the experimentation results. Another approach would be at the zip code level, where there would be more than 40,000 zip codes in the United States of America. However, it would not be uncommon to see people's home address and offices are in different zip code locations, and this allows users to be easily cross the control and treatment geolocations in a single day. And this would still contaminate the experimentation design. So with this consideration, the team decided to use a different approach. It leverages the Designated Market Area, or DMA in short. The DMA were originally designed by Nielsen for television and radio markets. It covers about 210 DMAs across the United States. A key property of the DMA model is that a typical user will not cross the boundary of their DMA over the course of a day, making it a much more desirable feature over the zip code approach. After understanding the granularity of geolocation, another complexity consideration for this splitting is how to ensure the split makes the control group almost the same as the test group. This ensures the metric behavior of the control and the test groups would be closer to identical if there were no change of action in the test group. Only in this way, when there is a change of marketing action in the test group, the metric differences can be interpreted as the market effectiveness measure. To achieve this, the team leverages historical metric performance of each DMA, applying both clustering and randomization techniques to create potential candidate splits. Then, the team leverages both backward historical metrics performance as well as forward-looking approaches, which is to use a hypothetical control group performance to predict the testing group's performance and see whether they match the most. The team eventually selected the highest performing split to use in their actual geo-experimentation setting. After discussing how to make the control and test split, the third component involves reading out the performance difference between the two groups. The team employs causal inference to construct a counterfactual that predicts the performance of the metric new active users as if the YouTube media had never gone dark and continued business as usual. This counterfactual will be compared to what actually happens in the test group to understand the channel's incremental impact. The team tested out two causal inference packages and eventually decided to go with the time-based regression framework, which can be directly calculated using an open-source package by Google. With the power of this causal inference methodology and package, the results can be readily interpreted. With all of these three components available, the team now can technically set up the geo-experimentation and get it running. However, it is also important to consider the business consequences of running such experimentation. The test group geolocations would have all marketing spendings turned off, and this could lead to fewer incremental new users generated in those areas. This is considered as the opportunistic cost of this experimentation, and it is a dedicated trade-off the team need to consider. How long the experimentation would run, as well as how large the geolocation segments to be used for the test group. Such trade-off consideration would ensure geo-experimentation is executed responsibly to address the right business needs without hurting the business in the long run. The team executed their geo-experimentation plan accordingly and discovered multiple insights that could alter how they handle ads throughout the year. This measurement strategy offers transparency and insights into the marketing effectiveness and used by the team to influence the company's marketing campaign strategy. Now that we've covered both the business problem and the technical solution, let's wrap it up. In this episode, we discussed how the data science team from Grammarly developed their geo-experimentation framework to measure marketing effectiveness. We talked about three components in designing an A/B testing experimentation, as well as considerations regarding the optimistic cost of experimentation to ensure its execution meets the right business needs. If you like the content of this episode, please subscribe to the channel, give me a 5-star review, and leave a comment. Your feedback is very appreciated, and I'll see you next week.